See, part one is solved. This is a simple linear inequality. You have to solve that one. So it is given that 3 over x is greater than 4. And we solve the inequalities in the similar way. We solve the equations. Take it to the other side. It will be 3 will be greater than 4x. So if you bring the 4 on that side, it will be 3 over 4 is greater than x. Or in other words, you can write it in this way also. X is less than 3 over 4. 3 over 4 greater than x, or x less than 3 over 4. And then you can show that solution also. It's actually 3 marks. So it's better show this solution also on the number line. This is the number line, if for example, and if we say this is 0, this is 1, 2, on this side -1, and so on, it can be 3 over 4. 3 over 4 is clearly between 0 and 1. So somewhere here, 3 part if your total parts are 4, so almost here you can say. And it is less than, so you can say make this one circle, and then less than values are on that side. So this is the solution of the part 1. Pretty simple. That 3 over x is greater than 4. We solved that one. We showed that solution that this line will follow all the solution which are less than 3 over 4. The second part is figure 1 shows a sketch of the curve C and a straight line L. You can see this curve C, which is clearly looking like it's a quadratic curve, okay? And there is a line L. This is line L. Both of these are intersecting at this point. Clearly, this is a point where they are intersecting, and it is on the x-axis. The line L and the curve are intersecting at the point which is on the x-axis. The infinite region R shown shaded lies in the quadrant 2 and quadrant 3. Like this is the region R, which is some part is in quadrant 3, some part is in quadrant 2, and is bounded by C and L only. Like this is bounded by, this is, you can say, the common solution region for this line L and this quadratic curve. So given that L has a gradient of 3, means you can say the given things in the gradient of the line L, it is given 3. C has equation of the C is given this one, that y is equal to 2x square minus 50. C and L intersects on the negative x-axis. They intersect on the negative x-axis. So use inequalities to define the region R. Now you have to use the inequalities to define the region R that is satisfied by them. For that, I must need to have the equation of the L, because equation of the curve C is given, that I have already. I need the equation for L. And to find any equation, you need gradient and at least one point. Gradient we have. To find the point, it's given, you can see both intersect on x-axis. And on x-axis, it means you can put y is equal to 0. Put y is equal to 0, you will get 2x square minus 50 equal to 0. And from here, I will have, sorry. I will have 2x square equal to 50, and then x square will be equal to 50 over 2. So x, take the square root on both sides, that is 25. So take square root on both sides, x will be plus minus 5. But it is clearly, question is saying that the line and the curve cut the x-axis on the negative x-axis. So that's why we will just consider the negative value. So that's why we have x is equal to -5 only. Now we got x. To find the y coordinate of that, this x I will put here in this equation. So I will get y is equal to 2 into -5 square minus 50, which is going to be clearly 0. Already we put 0, but if you want to verify, you can verify that also. So it means the point that this point, if you say this point P, so its coordinate are -5, 0. So this point is -5, 0. So at this point, now you have the gradient of this line also. It's clearly given that the line L has a gradient. We have the gradient of this line. We found the point as well. And after that, now what you have to do, you have to find the equation of L now. So for finding the equation of L, what I will do, I will use this one, y minus y1 is equal to m into x minus x1. This is ml that we have here. So what we will have now, if I will solve it here, so what I'm going to get now, it will be y minus y1. y1 is 0 actually, into 3 into x minus x1, which is minus 5. So we are going to get this equation as y is equal to 3 into x plus 5, which is going to be 3x plus 15. That is the equation of the line L now. And now using that one, it means the equation of the line L, if I write both the equations here, for the line L, we have equation of the line L is y is equal to 3x plus 15, and the equation of the line, equation of the curve C is given y is equal to, if we look at that one, it's given that y is equal to 2x square minus 50. So it is 2x square minus 50. That is the equation of the curve that we are having here. These are the two curves. But we have to make the inequalities. Now clearly, if you look at this one, this is the line L. And this is the curve C. Looking at this solution region, we can get one thing, and that is this solution, where this solution region is lying. It is above, below, or where is that exactly located? Because we have to make the inequalities to define the region R. So correct inequalities now we have to make here. So for making these correct inequalities, if you look at this one, this solution region is clearly above this one, yes? So it means you can say here that this inequality will be y will be greater than equal to 3x plus 15. Okay, and for this one, if you see, that is lying below that one, so you will say y is less equal to, because these are solid lines. Being a solid line, whenever you have the solid line, we use greater than equal or less than equal. So clearly you can see here, this is y is equal to 2x square minus 50. Solution is below it, mean you will say that y is less equal to 2x square minus 50, and this is y is equal to 3x plus what we get here, 3x plus 15. Yes, so if I will write this one, I will get here 3x plus 15. So it is above this one, it means you will say y greater than equal to 15. So that's why these are the two inequalities that you are having here. So simple question again, that was not difficult at all.